Fools! Fools! They laughed at me! Wait till they think about this! Ah!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by the brain. Without it, you wouldn't be able to understand what I'm saying. And that wouldn't be any good for either of us. Now would it?
You and I are animals. And like all animals, we control everything we do with our brains. Whether we're talking, waving, just sort of thinking about stuff, we do it all with our brains. Now, compared to the size of our bodies, humans have the largest brain of any animal on Earth. Now, you may have heard people say, you only use 10% of your brain. Well, that's not true. Use 100% of your brain all day and all night, even while you're asleep. You'll do it all with your brain. Like, suppose I want to do this, or decide to do this. I'm using my brain. Throw, catch, throw, catch, throw, catch, throw, catch, throw. Or picking up off the floor. It's all done with your brain. Your brain is a group of special cells that can send tiny electrical signals all over your body through something called the central nervous system. It's a bundle of nerve cells that runs inside your spine and then branches out all over the place. Now, nerve cells are able to send tiny electrical signals with very small chemical changes. It's kind of wild. That's what happens every time you move or think. So let's say that...
Hi, Ben.
You...
Me?
Yeah, you asked me to paint a picture of a tree.
Well, do it, man.
Okay. I think about it, and I remember what a tree looks like. And you look at that and you think, well, I guess that looks a little bit like a tree. See, it reminds you of a tree. Yeah, a tree. Now think about what happened. I had to understand that you asked me to draw a picture of a tree, or paint one. Then I had to remember what a tree looked like. Then I had my brain use my central nervous system to make my hand paint a tree. Now look, we're both thinking of trees. And that's just one image. That's just one tree. One piece of information. Just think about all the things that happen to you. Think about all the stuff that you can remember. All the things that you can plan. All the images that you keep in your head. Think of all the information you can store in here. It's wild. It's amazing. It's wild. Woo! Ah! Ah!
Have you ever made a great catch that surprised even you? Have you ever memorized a speech by repeating it over and over? Have you ever laughed when someone tickled you? You will. And the system that will be bringing it to you.
You can measure your brain's reaction time. Just have someone drop a ruler between your fingers. 19 centimeters.
Okay, it only takes like a split second for your eyes to send a message to your brain, and for your brain to think about what's happening long enough to tell your hand to pick up the ruler. So, the further the ruler falls, the slower your reaction time.
Check it out, though. If you drop the ruler through your own fingers, you respond a lot faster. See, when you open your top hand, nerves carry a message from one hand to the bottom of your brain, which automatically tells your other hand to close. Since you don't have to see the ruler drop, your reaction time is much better. You try it.
Okay.
Ready?
Stop, never mind.
The brain, spinal cord, nervous system control all of an animal's body functions. Even playing a video game requires all three to work in perfect unison.
There was something I was going to say. It was right on the tip of my tongue. Oh, yeah. I was going to talk about memory. Scientists like to think of humans as having 4 types of memory. We have our short-term memory. That's where you say things over and over again so you remember them. You know, call Steve, call Steve, call... That's why a lot of times it's easier to write stuff down. Then we have our long-term memory. That's where we remember important events or things that we do over and over again. And then we have our ancestral memory. Now, that's where animals remember how to do stuff right when they're born. Like birds remember how to build nests. Or humans remember how to get milk from their mom or from a bottle. And then we have our eidetic memory. Now, our eidetic memory is also called photographic memory. You know, sometimes you could remember where a picture was on a page in a book. Well, that's your eidetic memory. So there you have it, the 4 types of memory. They're
Short-term.
Short-term memory.
Long-term.
Long-term memory.
Ancestral.
Ancestral memory and...
Eidetic.
Yeah, eidetic memory. Yeah, eidetic. Can you remember all that?
Hi, everybody, and welcome to This Old Brain. I'm Bob Glia. Come on this way and watch that hoe handle there. We're going to work on the wiring of the central nervous system of This Old Brain. My buddy, Neuron Abrams, is over here. How you doing?
Hi, Bob. Over here.
What's the story on the wiring here?
Well, it seems this old brain had some damage inflicted upon it a while back. They probably weren't wearing a helmet.
That's tough. What do we do here?
Well, we have to hook these wires back up. You know, if the wiring's shot on the central nervous system, it makes it really hard for the arms and legs to receive that message from the brain.
The whole body, really?
Basically, yes.
Yeah, it looks like we need a lobe job in here, too. So I'm going to let you get back to work there, all right?
Okay, Bob.
I'll meet you down in the medulla later.
Okay, Bob.
All right.
Hi, I'm Charles Green, and I'm both a doctor and a brain scientist at the University of Washington. The brain is very complex, and each of the regions subserve a different function. When I'm out on the basketball court, I use the cerebellum, which is this part of the brain, to keep my balance when I'm running around opponents. When I wake up in the morning, I can smell my breakfast using this part of the brain, which is the olfactory cortex. The sensory motor cortex is this area here. It's not very well defined, but it's the part of the brain that allows us to move and to feel. And over here on the side is the temporal lobe, and inside of this area here on the temporal lobe is the auditory cortex, which allows me to hear. Inside of the cortex, this part of the brain, are thousands of tiny brain cells about the size of a pinpoint, and they communicate with the rest of the body by sending their processes out of the brain and into the spinal cord. Now, the spinal cord connects with all of the muscles in the body and tells them when to move. Using all of this amazing equipment allows us to study the electrical activity of individual brain cells. And in this way, we're beginning to understand how the brain as a whole functions. You know, brains are really cool.
This combination of cells seems to have no limitations. Unlike the most spectacular electronic brain, this machine can think for itself.
Extra, extra, read all about it. Brain is folded to fit in skull.
No wonder your brain's in the headlines. Think of all the information it can store. Think of your brain as a newspaper. It's folded. Just think of all the words, pictures, and ideas in here. They take up a lot less room when the newspaper is folded. You know, a newspaper has a lot of information. Just look at it all. All those pages in just one Sunday newspaper. Just think of all the information that must be in your brain. It's enormous, but it doesn't take up too much room because it's folded.
Hello, my name is Marty De Niron. I'm a filmmaker. Well, actually, I make TV shows for kids. You know that wacky scientist with the bow tie? That was mine. When I heard about Spinal Cord's tour, I jumped at the chance of capturing the inner workings of the brain. But enough of my gabbing. What do you say, let's rock? This is Spinal Cord.
Nigel, where's Mick the drummer? We're about to go on.
He's just exploded, left a green residue lying on the drum kit.
What do you mean he just exploded? How are we going to communicate with our fans? The spinal cord must remain intact if our music's to be relayed from our brains to the dancing bodies.
Hey, it's all right. We'll just turn the amps up louder.
But Nigel, they're already turned up to 10.
Well, use your noodle. Turn them up to 11. That's one louder, isn't it? Come on.
The skin of an orange and the rind of a melon protect the soft, squishy fruit inside. Your brain is protected too by thick, hard bone. But sometimes even your skull isn't enough protection. So use your head. Wear a helmet. Look, didn't even hurt it. Good as new.
So, Bob, when the wiring gets really screwed up, watch this.
Okay. What about if you did this one?
Well, go ahead and try it.
Okay, all right.
The brain interprets and stores information. So much information that if your brain weren't folded, it would never fit in your skull. Folding makes it fit. That's smart. What?
Let's say we wanted to take a picture of a brain. Let's say my brain. Well, we couldn't very well use a camera, could we? Because it wouldn't fit. Yeah, nah, I guess not. But we can take an MRI, a magnetic resonance image. And the way this works is, there's a very powerful magnetic field going this way, and then a radio wave goes through like this, and the two of them working together generate this crisp image. It's really cool. It's in here. Oh, you can't come in. You can't come in because there's a very powerful magnet, and it would ruin the videotape. Also, it's really loud. Here we go.
Looks like you did fine. They're coming up and they're very nice and steady. So here's his brain stem. So here's one eyeball, the optic nerve. Start into his ventricles here. White and gray matter, the little lining that's around the brain. This is his pituitary. This is a carotid artery coming up, major artery that feeds the brain. Should we get him out of there?
Right here is the snake's brain. This is a chicken brain. This is a rabbit's brain. This is a turtle brain, and these are its eyes. This is a human brain, just like the one that I have in my head, except mine's like the size of my fist. This part right here is where it connects down to your spine, and it's like a bone. This is like around here is where the touch is, and the motion is down below it. Your eyesight, your sense of vision, is the one that you use the most. The left side of the brain controls the right side of the body, and the right side of the brain controls the left side of the body. Brain power!
Look at all those cute little brain cells. Look at them. See, you and she and I all have about the same number of brain cells. We have the same number of brain cells when we're born as when we're grown-ups, about 100 billion. See, we never get any more. Now, if you cut your finger, you can put a bandage on it and it'll heal in a few days. If you break your leg, you can put a cast on it and it'll heal in a few weeks. But it doesn't work that way with your brain cells. We never grow new ones. So, you can damage your brain cells by drinking alcoholic beverages, taking drugs, or crashing your bike when you're not wearing a helmet. So be careful. Think about your brain cells. Are you thinking about them?
Here's an awesome way to improve your memory. Pick a room in your house and...
I know the perfect place.
Okay, let's go.
The prop room.
Okay, now spend exactly 1 minute looking around the room and memorizing everything you possibly can. Okay. Now, you leave the room and draw a picture of everything you possibly can remember.
Ryan!
Hi, I'm Jerry Andrus. I'm very interested in how our human brains work, and I'm standing inside what I call Box Impossible. And if you'll look, maybe you'll see that there seems to be something wrong with it. Here is a picture of just ordinary fluffy clouds, and now I'm going to spin this trizonal space warper, and I'm going to have you stare right at the center of it for 20 seconds. You keep staring right at the center of this trizonal space warper. Now we're going to show you that still cloud picture again, and you'll see that it looks like it's boiling. There's nothing moving about it at all. It just looks like it's boiling because you've been staring at the space warper disk. Got it figured out yet? Here's another one. This represents two large brass nuts. When I move them, they look like they're moving independently. Now I have a straight tube here. I'm going to push this straight tube through this nut, and you'll see that it looks like it has to bend in the middle to go through the other one. You see, the straight tube looks like it's bent in order to go through the other one. Now here again, your wonderful brain has just shown you something different than what it really is. This is made out of plastic, and you are looking at the inside of this. Our wonderful brain interprets something different than it actually is, but it doesn't mean that it's made a mistake. It took the information it had and it did its best job. Here, watch this. Look, it's not a box at all. I was just standing in the corner of this framework, and you can see it has no resemblance to a box at all. And your wonderful brain interpreted that picture on your retina as a box.
Now let's try this one and that one and all three of them at the same time.
Let's try it and see what happens.
All right.
When I'm talking, the part of my brain called the cortex is sending millions of signals to my mouth and tongue so that I can form words and make sentences. Also, this ballet dancer of science is sending millions of pieces of information all over his body so that he can plier and relever and jeter. Not bad. You know, your brain is as active when you're asleep as it is when you're awake. In fact, let's run a test right now. Yeah, a little shut-eye. It's not bad.
The Nobel Prize for the most scientific-like brain goes to that wacky science guy.
Huh?
My name is Chris, and I'm an ultra runner. And after 90 miles, it's my brain that keeps me determined to finish the race. Hopefully this summer I'll finish a 100-mile race. Running long distance is more of your brain than it is of your body. Once your body's in tune, you know it'll get you there, but your brain is the one that really gets you there. If you don't think you can do it, you can't do it. But if you think you can do anything.
Okay, one last time. This is a hot frying pan. This is your brain reacting to a hot frying pan. Ah! Wow! Oh, man! What a stupid thing to...
Yeah. Yeah. What a brain, what a brain, what a brain, what a mighty good brain. Say it again now. What a brain, what a brain, what a brain, what a mighty good brain. It's a mighty, mighty good brain. What a brain, what a brain, what a brain, what a mighty good brain. Oh, yes, it is now. What a brain, what a brain, what a brain, what a mighty good brain. I wanna take a minute right now while we have a law to talk about the great stuff that's inside your skull. It's the most important organ, and we know that it's true, cause it controls every function that your body can do. But your brain's not selfish and it ain't no jerk. It's got the spinal cord to help out with the work. And don't you be thinking that it's to the crew, cause the central nervous system's helping out too. Call it team brain. What a brain, what a brain, what a brain, what a mighty good brain. Say it again now. What a brain, what a brain, what a brain, what a mighty good brain. Oh yeah. When it comes to memory, your brain's no snob, cause storing information is a serious job. Long term, short term, ancestral and eidetic. With 4 types of memory, it gets pretty hectic. Now's the time of the song where we say goodbye. Gotta make room for the big brain, Bill Nye. So pay close attention and use the refrain. Your most important organ is your mighty good brain. What a brain, what a brain, what a brain, what a mighty good brain. Say it again now. What a brain, what a brain, what a brain, what a mighty good brain. It's a mighty, mighty good brain. What a brain, what a brain, what a brain, what a mighty good brain. Oh, yes, it is now. What a brain, what a brain, what a brain, what a mighty good brain.
Everything looks okay. That's my brain. And that's our show. Thanks for watching. If you'll excuse me, I've got millions of synapses to forward and neurons to fire. See ya!
Produced in association with the National Science Foundation.
Science! Science!
No, it's not science, it's science!
Science!
No, science! Use your cerebral cortex, which is connected to your neurons and all the other stuff inside your body going down your spinal cord via some ganglia or something like that.
Science!
No, science. Science? Science.
This wiring shot, Bob. But watch what happens when you do this.
How about if you hook that one up?
Well, let's see what happens, all right? Go ahead and give it a try.
Okay, all right. Here we go. Oh, boy. Here we go.